Assalamualaikum and good day everyone. Today we are going to continue our lessons on the topic of forms of corrosion. And today's discussion is about the erosion corrosion. Erosion corrosion, sometimes we call it flow-induced corrosion. It's happened in many engineering structure, okay, which operate with electrolyte flowing either through or around them. So this flow can increase the transport of oxygen to the metal surface. But in this situation, it may help to passivate because it supplies the oxygen. There is no issue in the oxygen depletion that will allow the oxygen concentration cells in the system. So they increase the rate of dissolution of corrosion. Product forms also may cause the erosion corrosion because of this corrosion product that's supposed to inhibit the further corrosion is already dissolved in the flow. So if it is stagnant, maybe the dissolution is a bit less, but due to the flow of the electrolyte, then this may happen, which is dissolution of corrosion product. So, in fact, if there is a corrosion protection applied where there are an oxide films developed in the surface of the metal, this flow can mechanically remove this oxide layer. Okay, so the type of flow-induced corrosion include erosion corrosion, cavitation, and fretting corrosion. So look at the first one, which is the erosion corrosion. So erosion corrosion may attack in metals that occur due to the relative motion of the corrosive fluids and a metal surface itself. The corrosion is accelerated by the impact of solid particle on the surface. Okay, so this particle may remove a metal. Okay, this particle that attack the surface will remove the metal, or they just may remove the oxide and allow the metal to corrode more quickly. So let's say, for example, if the metal having chromium oxide, okay, or an alumina layer, so this is a passive film, or in fact the coating, okay, paints, this is the best material. So once it's destroyed these passive films, this exposed area will turn itself into which is active materials, will react with the environment and allow the corrosion. The first cases is the metal itself remove the particle itself remove, or the flow itself remove the metal, and you may see the degradation at the surface. But another phenomena is when the passive films is destroyed, so the base metal will react with the electrolyte through the electrochemical reaction. Okay, for example, burst left at cut tube end can upset smooth water flow, causing localized turbulence and high flow velocities, which in turn resulting in erosion corrosion. So whatever the defects, okay, for example, this is your pipeline, there are some defects somewhere here, okay, like a burst or cut tube ends, for example, like this one, you cut this tube, there are some imperfection. So the water flow, okay, will be interrupt somewhere here, and this may give a localized turbulence. So this may allow the high flow velocity, which allow the erosion corrosion. So erosion corrosion occurs in valve, heat exchangers, tube, pumps, and at the elbows and teeth junction in pipeline, and any structural features that change the flow direction or velocity of the liquid flow or gas flow and increase the turbulence at that particular area. So this is where erosion happen. So how to avoid this? Choose the correct materials. Okay, material selection plays an important role in minimizing erosion corrosion damage. So you can choose material that high wear resistant, so that it won't damage due to the impact particle inside the liquid flow or the gas flow. And besides, through the design, it is also important. It is generally desirable to reduce the fluid velocity and promote laminar flow. And this increased pipe this can be done through the increase the pipe diameter, and this may help the fast changes in the liquid velocity. Rough surface are generally undesirable. So because rough surface will interrupt the lamella flow of the liquid or gases. So design creating turbulence, okay, flow restriction and obstruction are supposed to be avoided, and abrupt changes in the flow direction should also be avoided. Okay, just a slight changes or a smooth curve, okay, rather than sharp curve is preferred. So the second types of the erosion corrosion is the cavitation corrosion. This cavitation corrosion is a form of erosion corrosion, and it is actually caused by the formation and collapse of bubbles of the vapor. So if there's bubbles and this bubble is collapsed, so it will give some pop impact on the surface. These vapor bubbles form because of the pressure changes, okay, which is for less than 0 atmospheric pressure, and across the surface exposed to high velocity liquid flow. So when the pressure increases again, the collapse of the vapor bubbles creates an intense shock wave that remove metal or oxide from the metal surface, okay, just because of these bubbles only, due to the changes of pressure. So how to prevent the cavitation corrosion? We can carefully design or minimize pressure drop across the metal surface. We can optimize the material selection, high wear resistant materials, okay, environmentally modification. Make sure if there's a involved liquid, gases in your system, any system like a boiler or any plant, make sure that you filter all the particle, solid particle, okay, maybe you can eliminate poison gases such as chloride and everything. So this can modify the environment. So abrasive particle in fluid can be removed through the filter, de-aeration to remove of air, or maybe some kind of a filter for the gases. You can remove any possible ions, for example chloride or sulfide. So this may ensure that the liquid entering your system is clean liquid or gases. And besides, you can allow the cathodic protection in the system. For example, you allow your pipe to become a cathode through the sacrificial anode, sacrificial cathodic protection, or by the SCCP. Okay, and also you can use coating, okay, to avoid this kind of the cavitation corrosion. For example, rubber can absorb the shock wave. So you soft coating, you can apply soft coating on the surface of your metal. And next types of erosion corrosion is a fretting corrosion. So fretting corrosion is a damage that occur at the asperities of the contact metal surface. Okay, what is asperative? Let's say you have this rough surface. Okay, this is asperities. Okay, it occurs at the interface of two highly stressed surface in the presence of repeated relative surface motion, like this one. Okay, movement at this direction, and there is a friction between the two interface. Um, uh, okay, so example of relative surface motion is the vibration. The surfaces are not designed to move against each other. So this is a kind of the fretting corrosion that may occur. The most common type of fretting is caused by vibration. The protective films on the metal surface is removed by the rubbing action and expose a fresh active metal to the corrosive action of the environment. So during this friction between the two surfaces, let's say initially you have a passive film, okay, due to repeated process, maybe due to the vibration, this passive film may be removed and allow this base material, which is active materials, which is need to be protected, are exposed to the corrosion atmosphere. Austenitic stainless steel, titanium and aluminum alloy, basically they have adherent protective films, the oxide layer, titanium oxide, aluminum oxide, or chromium oxide. These kind of metal are the most susceptible to fretting corrosion because they are relatively soft material. Okay, protective corrosion can be minimized by careful design. Okay, design the part to exhibit less or relative motion. Use a lubricant, okay, on the contact surface so that it will become smooth. Use insulation material between the surface so that it can absorb any vibration impact. Reduce a load between the surface, and this may reduce the effect. And select more resistant materials. So that basically this is related to high wear resistant material because the effect is only happen at the surface. So wear resistant basically hard materials that avoid any wear effects due to the erosion corrosion. This is an example of fretting that occur between this movement contact surface. So due to any highly load surface, this surface is corroded between these two contact surface. I think that's all for the erosion corrosion. Thank you.